Good morning, it's Wednesday, and we are going to read a story called Seymour Simon, Insects. Now, this is a nonfiction book, and remember, nonfiction books, information books, are to inform. They're to tell you about something. And obviously what this is going to tell us about is about insects, and it says all about their bodies, senses, life stages, and more. And those are the things we're going to look at today. Now, when you read a nonfiction book like this for information, you do not have to read it from cover to cover. You can either look at the table of contents if it has one, this one doesn't, or you can flick through the pages until you find the part that you want to read. Now, we're certainly not going to read this whole book today because it's very long, and see, it has pages very close together. But it has a lot of really great information in it, and so I'm going to read some of it. Many people call any insect they see a bug. That's fine, even though it's really not scientific. All bugs are insects, but not all insects are bugs. It's as if you were calling all mammals cats. It's true that all cats are mammals, but not all mammals are cats. There are many other kinds of mammals that are not cats, such as dogs, elephants, whales, and even people. According to scientists, bugs are only one group of insects. Scientists divide all insects into about 25 different groups. 25 different groups of them. So you can still call them bugs if you want, but scientists would not call them bugs. They would call them insects. Calling them bugs is the same thing as calling them creepy crawlies. It's very similar to that. All insects are invertebrates. Remember, we talked about that yesterday. And here's a black ant, which many of you saw on your safari, because they're everywhere. And look at how they have three distinct body parts. And let's count their legs. 1, 2, 3, 4, 5, and there's one more on the other side of this one. You can just see it right back here, the little shadow of it. 6, and then it has 2 antennae. And here's its mouth parts up here. See that? That's a black ant. Spiders are often mistaken for insects, but they're not. Spiders have 8 legs rather than 6 legs. Unlike insects, their bodies have only 2 parts, the head and the abdomen. Whereas an insect, let's go back to this beautiful ant here because he illustrates it very well. An insect has a head, an abdomen, and a thorax. 3 body parts. Spiders also don't have antennae, and they don't have wings. There are many other small, creepy, crawly things, such as centipedes and millipedes, that are not insects because they don't have the right number of legs or body parts. So remember, if it's an insect, it has 3 body parts and 6, there's one more finger, legs. Let's count the spider's legs. Let's see. Let's count by 2s because they're pairs. 2, 4, 6, 8 legs. And look at the millipede. That's very hard to count how many of those legs are. We have that exact same millipede that lives in North Carolina, those same colors, that blackish purple, and all of those legs. It has antennae. It has a lot of things that are the same as an insect, but many things that are different, including many different body parts. Look at all these body parts, and look at all these groups of legs. Legs are paired. They have each side of the body has the same amount of legs as the other side. They have pairs of legs. Baby animals, such as kittens and puppies, look pretty much the same as they grow into adults. They just grow bigger. But many insects change shape and look completely different as they grow. This is called metamorphosis. Metamorphosis for ants, bees, beetles, butterflies, and other insects has 4 stages: egg, larva, pupa, adult. We've all seen that. Insects begin as eggs. They hatch into a soft worm-like shape called a larva. You've seen a larva if you've ever seen a caterpillar, which is the larval stage of a butterfly. Larvae are big eaters. They continuously eat. They can eat several times their own body weight every day. If a human baby grew as fast as an insect larva, he or she would grow into a giant. And there's a caterpillar eating and eating and eating. Remember, the caterpillar is the larva. There are at least 4 times more kinds of insects than all other kinds of animals combined. So let's think about what that means. Remember, an animal is anything that's alive that's not a plant. So anything that's alive that's not a plant. Birds, mammals, reptiles, amphibians, insects, anything else. And if you take insects just insects, and then you take all of the other things, birds, mammals, reptiles, amphibians, many other different kinds of things. I can't think of them all right now. But if you took all those and multiplied it times 4, so that means you have one set in the whole world, and then you make another set that's equal, and then 2 more that are equal. You took 4 times that many, you would still have more insects, way more insects in the world than that. So insects, that's the most populous kind of animal in the entire world. Some insects are as small as a period at the end of a sentence. That's pretty small, just a dot, because remember, we don't make big circles when we make a period. Others are 2 or 3 inches long, 2 or 3 inches long, like that. Remember, a dollar bill is about 6 inches long, so half of that would be about 3 inches. All right, here's a praying mantis, insect. Now, the next one I'm going to show you is called a spiny, look at this caterpillar here, is a spiny leaf insect, because you tell me why, look at it. Why do you think we call that a spiny leaf insect? Why? Because it looks just like a spiny leaf, doesn't it? It looks less like an insect than it does the leaf that's going to camouflage itself with. Pretty cool. Scientists think that the number of individual, that means one, insect alive at any time is 10 quintillion. So it looks like this: million, billion, trillion, quadrillion, quintillion. Oh my gosh. I can't even tell you how many. That's a 10 with 18 zeros behind it. That's a big, big number. And that's why we see so many insects. You may see around your house snakes like Oliver did the other day, or you may see bunny rabbits, or you may see squirrels. They're everywhere, aren't they? But not like you see insects. Insects are everywhere. We see them everywhere, 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 everywhere. Dragonfly fossil. If you could, now look at this carefully, because this is what our job for today is. We're going to make, I think that's our job for today, is to make a fossil. Let me see. Yep, that's what we're going to do. So this is a fossil of an insect. Now, a fossil is where animal or plant life, something that's made out of life, something that's life, that's living and not living, gets trapped in mud, and then the mud hardens into rock over millions of years. And because it's trapped in there, the impression that the dragonfly makes is left inside the rock. And we're going to make an example of a fossil today. That's going to be our job today. And then you're going to write the instructions of how you did that. Because writing step-by-step instructions is one of the things that we have to do in school. It's one of the things that we're required to do. So that is one way that we know what used to be here a long time ago, is by looking at fossils. Now, you can see I'm skipping some pages because this book is too long to read the whole thing. It's a very, very good book, though. And we're going to read some more. I'm going to read a little bit more of it before we're done. Bees and wasps here they are. See them? Bees, that was a bee, and this is wasps. Bees and wasps belong to an order of insects called Hymenoptera. Their name comes from the Greek meaning winged. Ants are in the same order, but most ants are wingless. Only the queen and the reproducing male ants have wings. The workers in ant colonies have no wings. So if they're workers in the colony, they don't have wings. If they're queens, or the males that help the queens to lay eggs, then they have wings, because they need to come and go easily. Pretty interesting. Insects are alike in this way. Bees and wasps have gauzy means see-through wings. The front wings are bigger than the back wings. Many of the insects in this order, such as ants, live in large groups called colonies. The young look like tiny worms or grubs. Remember the larvae that we saw in the picture from yesterday? I held the beehive really close to the camera, and you could see the larvae inside there. The adult females have stingers. They have chewing and sucking mouth parts. The middle of their bodies look pinched together, kind of like if you were to make them out of Play-Doh and you pinch the Play-Doh together. It looks like that. That's interesting, isn't it? Butterflies and moths belong to an order of insects called Lepidoptera. The name comes from Greek meaning scales, because they have scales on their wings. Look at this. Kind of like snakes have scales, but butterflies also have scales on their wings. Isn't that interesting? They're not related to snakes, but they have scales. They have a similarity with one of the overlapping parts of the Venn diagram would be scales between snakes and butterflies. Another one would be that they're living creatures and that they're in the animal kingdom. That would be part of it too. Butterflies and moths are similar in these ways. The adults have 2 pair of large wings. They have caterpillars that are wingless. They have sucking mouth parts. They have chewing mouth parts. They have antennas with knobs on the ends. But moths have feathery antennas. Butterflies have antenna with knobs. Moths have antennas with feathery antennas. And larvae form cocoons during pupa stage before they emerge as adults. Here they are. See, they're coming out of the pupa. And then they're a moth. Isn't that beautiful? Okay. So your job today is to find some Play-Doh or make some Play-Doh. I'll put a recipe up for you to do it. And then find something in your house that you can make a fossil out of. You're going to take just a minute, Elizabeth. You're going to take the Play-Doh. You're going to put Play-Doh here. You're going to put whatever it is you decide. It could be a Lego figure. It could be insect. It could be a rock. It could be anything you want. Just a minute. Thank you. Thank you for your flower. Thank you. Elizabeth brought me a flower. And then you're going to put your thing there, and you're going to put your other piece of Play-Doh over the top, and you're going to squish them together. And pull them apart, and you'll be able to see the impression of the thing that you chose in your fossil. So please take a picture of your fossil. I can't wait to see it. If for some reason you have plaster, you can make an almost real fossil because plaster dries really, really hard like a rock. All right, I can't wait to see your fossils. I love you.